Hello students. So let's solve some 1 or 2 marks questions. Okay. If theta is the angle between the vectors A and B and mod of A dot B is equal to that magnitude of A cross B, right? Then you have to find theta. Okay. So here this thing is given and these things are there in the cos theta, which is A dot B upon A B, and sine theta magnitude of A cross B on this. Okay. Now these things are equal means our cos theta and sine theta is equal, and we know that for the angle theta for which cos theta and sine theta is equal is for pi by 4, which is 45 degree. Okay. Sine theta is 1 upon root 2 and cos theta is 1 upon root 2. Okay. Let's solve second one. Find direction cosines of the normal to the plane. Plane is given x plus 2y minus 3z plus 4 equal to 0. This is a Cartesian equation, right? So the normal vector is given by 1I plus 2j minus 3k. Okay. And how we write direction cosines? So these are the direction ratios. 1, 2, minus 3. Okay. Direction cosines are 1 upon root of 1 plus 4 plus 9, 2 upon root of minus 3 upon root of. Okay. So the direction cosines are 14. Okay. Next you have to find if the lines are perpendicular, then you have to find P. Okay. Now here the thing is in this case it's not, in this case you don't have to write it in the general form, but I'll just show you how to write this in the general form. So general form of a, that is Cartesian equation of a line is given by x minus x1 upon a, y minus y1 upon b, and z minus z1 upon c, right? So where our a, b, c are the direction ratios. Okay. So we have to write this. So the equation is x minus of minus 3 upon 2, y minus 1 upon 5. Second is so to find angle we need cos theta equal to a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square, a2 square plus b2 square plus c2 square, right? Now here the information which is given is they are perpendicular. Perpendicular means theta is 90 degree and cos theta is 0. So whenever theta is pi by 2, which is 90, we have the equation a1 a2 plus b1 b2 plus c1 c2 is equal to 0. Okay. This is our a1 a1 b1 c1, a2 b2 c2. So 2 into 1 plus 5e plus 20 is equal to 0. So this is 22 minus 22. So P is minus 22 upon 5. Okay. into 1 to 3. Okay. Next is you have to find the angle between the planes. Okay. So here the planes are given in the Cartesian form. So this is a1x plus b1y plus c1z plus d equal to 0. a2x plus b2y plus c2z plus d2. This is d1 equal to 0. So this 5 you have to take here. Okay. But there is no need of d. So our formula is cos theta equal to a1 into a2. So 3 into 2, 6 plus b1 into b2 minus 4 into minus 1, 4. c1 into c2, 5 into minus 2, minus 10 upon root of 3 square, 9, 4 square, 5 square, 2 square, 1 square, 2 square. Okay. It comes to be 0. 10 minus 10. So cos theta is 0. So theta is cos inverse of 0. So angle of which the cos is 0 is 90 degree, right? So theta is pi by 2. Next question, the scalar product of the vector I plus j plus k with unit vector along sum of the vectors is equal to 1. You have to find lambda. Now here 3 vectors are there, right? So if I take this A to be I plus j plus k, B is 2i plus 4j minus 5k, and C is lambda I plus 2j plus 3k. Okay. Now here the thing given is scalar product of the vector with the unit vector along the sum of the vectors. So you have to add these two vectors. Okay, and then you have to find the unit vector of that. So sum of the vectors b plus c, you have to just add them. 2 plus lambda, 4 plus 2, 6j, minus 5 plus 3 is minus 2k. Okay, now finding out the unit vector. Cap magnitude of this 2 plus lambda I plus 6j minus 2k upon root of 2 plus lambda the whole square plus 6 square plus 4. So this will become 40. So I will keep this as it is. Okay, now it is given that scalar product of the vector with the unit vector. So scalar product, that is scalar product is dot product and vector product is cross product. Okay, A dot this vector. Okay, is 1. Okay, so I plus j plus k dot this thing 2 plus lambda I plus 6j minus 2k on 2 plus lambda the whole square plus 40 equal to 1. Okay, now this is a scalar quantity, so this gets multiplied here. This you can do the dot product. So this becomes 2 plus lambda plus 6 minus 2 equal to root of 2 plus lambda the whole square plus 40. Okay, now we have to remove this root. So squaring both the sides, this is 2 minus 2 gets cancelled, lambda plus 6 the whole square. Okay, expand it, lambda square plus 12 lambda plus 36. 2 plus lambda the whole square is 4 plus 4 lambda plus lambda square plus 40. Okay, so 12 lambda minus 4 lambda is 8 lambda, or 44 minus 36. Okay, 8. So lambda is 1. Okay, next question, you have to find the Cartesian equation of the line passing through the point. Point is there and perpendicular to the plane x plus y minus z equal to 6. So this line is perpendicular and this point is on this line. Okay, normal vectors here, normal vector is 1, 1, minus 1. Okay, so this becomes the direction ratios. Okay, so the Cartesian equation of the line is given by x minus x1 upon a, where a, b, c are the direction ratios, right? So we can write x minus 1 upon 1, y minus minus 2 upon 1, z minus 5 upon minus 1. This is the Cartesian equation. Okay. Next question, find unit vector perpendicular to the vector I minus j and I plus j, forming a right-handed system. So the two vectors are taken. The perpendicular vector is the normal vector, that is we find a cross b, correct? So we have to find the unit vector of that. So you can write I plus j cross I minus j. Okay. 0, 0, minus 1, minus 1. So minus 2k. Now we have to find a unit vector. Unit vector is given by I plus j cross I minus j upon magnitude of I plus j cross I minus j. Okay, minus 2k upon root of 4, which is 2. So this is the vector minus k. Okay.